Hi, everybody, and welcome to my channel Numbers with Nora. This is a math tutoring channel that helps you with all your math needs, homework help, any other math questions that you may have. This is the channel for it. For this specific video, I'm going to be doing Geometry Chapter 7. I'm not sure which book my student is using because she gave me screenshots, but this is going to be mostly about quadrilaterals. Okay, so you can follow along in your book when it has to do with quadrilaterals or any homework or whatever like that. Okay, so let's get on with the lesson. So this is the screenshots of the homework that she sent me. All right, so this would be good practice too if you don't have this book, if you're doing quadrilaterals. All right, so the first thing I want to get into before we start looking at these, for number 1 through 3, it says find the value of each variable in the parallelogram. First of all, I want to sit there and look at the properties of parallelograms, like what makes a parallelogram a parallelogram. And it's going to be these 4 things right here. So a parallelogram has to have opposite sides that are congruent and equal. It's going to have opposite angles are congruent. The sum of the interior angles is 360. Also, the sum of the exterior angles are 360 as well. And then consecutive angles equal 180. So these 4 things have to happen in order for it to be a parallelogram. Okay, so I put this as like a little chart right here because we're going to keep on coming back to that, okay, throughout this lesson. All right, so let's go ahead and do 1 through 3. So again, find the value of each variable in the parallelogram. All right, so looking at 1 right here, since they already stated that this is a parallelogram, then I sit there and know that my diagonals are equal, and I also know they create a midpoint. Okay, and I can conclude that only because they let us know right off the bat that this is a parallelogram. All right, so since that's a midpoint, I know that this breaks my whole segment into 2 equal parts. All right, so my S is actually going to be equal to 3.5. All right, by definition of midpoint. And then also 6 in this one, these 2 parts are congruent. So my R is going to be equal to 6. Okay, equals 6. Perfect. All right, let's look at 2. So for this one, remember they gave us this parallelogram. So my opposite angles of a parallelogram are congruent, right? So I already know that B is going to equal to 101 or 101 degrees. And I know A. Okay, now remember right here, I can use this. There's a couple of ways I can find A, but I know that consecutive angles of a parallelogram are equal to 180. So I could sit there and say these are consecutive angles, my A and my B. All right, so that means I know that my angle A plus my angle B, they're supplementary. I know B is 101. Okay, that's just substitution right there. Has to equal to 180 degrees, all right? So if I sat there and wanted to solve for A, I just subtract 101 from both sides. All right, and that's just going to give me A equals 79 degrees. All right, 79 degrees, perfect. All right, so let's go ahead and scooch on over and look at 3. For 3, again, I'm using my properties. One of my properties that, since they told us it's a parallelogram, my opposite sides are congruent. So we know this P is going to be equal to 5. All right, because those are opposite sides. This side right here and this side are congruent, so I'm going to have to sit there and set up an equation. The equation I'll set up is 6 is equal to Q minus 3. Okay, I want to solve for Q, so I add 3 to both sides, 6, 7, 8, 9. So I'm going to get Q. I always like writing my variables on the left-hand side because I added 3 to both sides equals 9. All right, and that's the answer for, oh, I'm not done because they wanted us to find Find the value of each variable. Oh, we just had to find the value of each variable. If you want to check your answer, you can plug this back in because Q is 9. 9 minus 3 is going to be 6. And we said both of these opposite sides are supposed to be parallel, which is correct. So yes, right? Also, if you want to check your answer for number 2, we could sit there and say opposite sides are opposite angles are congruent. So this would be 79. Add up all of your interior angles. All of your interior angles, the sum of them, are supposed to be equal to 360, which you will get 360. Okay. And that's another way you can check your answer. All right. So let's go ahead down to 4. Give the most specific name for the quadrilateral. Explain your reasoning. All right. So I'm going to show you a little cheat sheet, and you can sit there and use this for your homework and to help you memorize what type of quadrilaterals we have. So there's going to be 1, 2, 3, 4, 5, 6 different types of quadrilaterals. And in blue down here, it tells you why they are these types of quadrilaterals. All right. For example, usually a kite, both of the adjacent pairs or the sides that touch each other are going to be congruent. Okay. And most of the time it has only one right angle. All right. And so on and so forth for these properties. Okay. So I put this one on here because it's going to help us with 4 through 6. All right, so let's look at 4 first. For this one, we kind of want to see what kind of quadrilateral it looks like. I noticed that it has, for number 4 I'm focusing on, it has 2 90-degree angles, right? Let's go back down to my chart. I want to look for something that has at least 2 90-degree angles. This doesn't have any 90-degree angles, so I know it's not going to be a rhombus. I know it's not going to be a parallelogram because parallelograms don't have 90-degree angles. Trapezoid has 2 90-degree angles and 2 sides are parallel. Even if I sit there and draw a dotted line, this kind of looks what I need, like what I need right here. I know it's not going to be a kite because a kite doesn't have 2 90-degree angles, okay? It's not going to be a square because this has 4 90-degree angles, and it's not going to be a rectangle because this has 4 90-degree angles. I'm stuck with the trapezoid, okay? So for 4, I'm going to have 4 as a trapezoid, okay? For right now, I'm just going to put trap because I don't want to have to sit here and spell the whole thing out. Trapezoid. And even if we did sit there and do this, notice how they have that in that trapezoid down there. And it says it has 2 parallel sides. If I sit there and draw a dotted line from this point to this point, kind of does have 2 parallel sides right there. Okay, now let's look at 5, some of the properties. So some of the properties I have for 5, I noticed that both my sides that touch are congruent. Same thing for the down here. Both my sides that touch are congruent, and I only have 1 90-degree angle. So most likely we want to go down here and look at our chart and see which quadrilateral looks like that. It's not going to be a rectangle. It's not going to be a square. It's not going to be a rhombus. It's not going to be a parallelogram because my opposite sides are congruent for a parallelogram. Not going to be a trapezoid because I have 2 right angles right here. It's going to be a kite. All right. So that one's going to be a kite. So this one's a kite. All right, so then let's look at 6. For 6, we're going to sit there and go back in time a little bit to where we had the triangle postulates. And I'm going to use the postulates to sit there and see what kind this is, right? Because they don't give me that these opposite sides are congruent. So I just want to double check that before I can sit there and start marking up stuff that they didn't give us. I'm going to cut my polygon into 2 triangles. I notice if I do sit there and have 2 congruent triangles, then I can start sitting there saying certain sides are congruent. So this line that I created for the 2 triangles right here, I know that those sides are congruent because of the reflexive property. They already told us what angles are congruent, right? So I know this angle is congruent to this angle because I'm just cutting it in half. So I can actually use a postulates here. I can use angle, side, angle. Remember that postulates? If you don't remember that postulates, go back to my videos in chapter 4. Okay. So that's angle, side, angle postulates that I can use. And since that I sat there and found the postulates I can use, I can sit there and say that these two triangles are congruent. Okay, since they're congruent, they have corresponding congruent sides. This side corresponds with this side, and this side corresponds with this side. Okay. I believe. And so since I have opposite sides that are parallel, this is going to be a parallelogram. Opposite sides are parallel. Okay. So we're going to have a parallelogram for number 6. If you have any questions on 4 through 6, leave something in the comments and I'll answer back in the comments or try to explain more. Okay. So this one's parallelogram. Okay. And I'll just put, you guys get the point. Parallelogram. I don't like drawing with or writing with this pen. It's not made for writing. Okay. All right, so let's go on to 7 and 8. So 7 in a convex. Okay, I'm going to explain what that is in a second. In a convex octagon, 3 of the, okay, always annotate what they're giving you, okay? 3 of the exterior angles each have a measure of x. Okay, that's important. The other 5 exterior angles have a measure of 2x plus 7. They want us to find the measure of each interior angle. So we're finding the measure of each angle, right? So a convex polygon is basically, oh, I think I wrote the definition down here, okay, and more of my notes. Right here is what I'm looking at, okay? So a convex polygon is all the interior angles of a convex polygon are less than 180 degrees. All right, that's one way to say it. All right. And then also we have that we're dealing with the octagon. So there's going to be 8 different interior angles that we're dealing with. 3 of those angles are just equal to x. The other 5 are equal to 2x plus 7. All right. The formula for finding the exterior angles of